Hey, in this video, we are going to talk about records. My name is Gary Taylor, but that's not really important. I want to talk about how I've been using records, how I've seen records being used in .NET, and how I think we want to progress in the future, and how I'm going to start working with my teams and things to try and make the best out of records. So let's get started. A lot of the stuff that I am going to talk about is been from Zoran, and also just by reading the specifications and going through all of the documentation on records on the website, and of course having used them as like primitive DTOs. But first, let's get started. Let's dig in and have a look at what records are. All the information is going to be in the comments as per usual. I'm even going to point to a post where you're going to be able to read the documentation. So let's see if I can work my way through this. Just bear with me. So grab this screen. Right. So .NET Records was introduced, I think, around 2020 in C#9. And it highlighted a shift in object-oriented, domain-driven, I'll talk about that in a sec, programming towards more functional style programming, building simple objects, being able to construct them, pass data around, but also by making them immutable, which means they can't change. Once you set the values, that's it, them values can't change. So let's talk about what records are and have a bit of an example and why I think a lot of people are misusing them. So let's create an example where we have a building. We're building a model, sorry, to represent, say, a person. And there are a number of properties that are required. So you've got a person with first name and address, which is an array. And the address has got some details in it. There is a meter, so if you've got gas or electric, you will have some form of meter, and that meter is managed by a provider. So there's a relationship here, right? And we've got a person that has addresses, each address has a meter, and each meter is associated with a person. And how many people here, raise your hands, are writing classes and populating and writing all of this boilerplate code for first name, surname, address, postcode, address line 1, provider, and keep on populating and creating these classes. So it's common to actually code these classes, and they are really just data objects. They are really just things that hold data, and they don't have any purpose. They're just DTOs, data transfer objects. And in code, we are used to that. Whenever we pass data from an API call and it goes all the way through to the database, it's generally passed in as these data chunks and kind of manipulated as it go. So instead of writing all of this code, what we can do is we can use a record. And a record is syntactical sugar, a way of being able to represent all of this, but within one line of code. So when we do this, a class is being created, a constructor is being set up. The constructor has got these properties and it has these public methods. The difference is that the set is actually an initializer, an init, and therefore can only be set when the class is first initialized, which makes them non-changeable, immutable. So that's the core difference. There is also lots of other things sprinkled into a record that you wouldn't generally write yourself within a class because you couldn't be bothered and it's just hard work. So we'll look at that in a sec. So let's see if I can go to a coding example. So here, what I'm doing is I am using remember the name now, but basically I've got the ability to just write scripts within C# within VS Code. So as you see, you write a line there and you can see hello world. What I'm going to do here is I'm going to import some NuGet packages. Now you don't need these NuGet packages. These are just ones that I've wanted to include just to make things easier. Then get the using clauses, and then I've got a method just allows me to print the screen, so I can do things like print params instead of having to console write all the time. So let's get to it. Here's the class. If I just zoom in a little bit, because I think that's a little bit small. So here's the class person. You can see first name and surname. You can see the constructor with parameter arguments in a certain order, which is first name and then surname. So the first parameter I've got to pass in is the first name, and the second one is the surname. So if I run this, there isn't any surprise that if it works, that I get out a person object. And that's because it's a person class. So this is a person object, and I've got an instantiation of that object. Now, if we change that and we use a record instead, what we're able to do is get rid of all of this boilerplate code and just create a surname, first name, and I'm just going to add an age with a default of 21. I wish. Now, when we output this and we've got me and you, what we can see here is that me has a default age of 21 because I didn't pass it in, and you has an age of 42 because I did. But something you should also be able to see really quickly is that this appears to be JSON-ish data. We can see that instead of just getting the object to string, which doesn't work right because you can't just to string an object. Well, actually with records, you can. When it constructs it, it constructs a to string, and it uses code generation to actually be able to populate all of the data objects. And this works even with nested or inner properties, which is just really useful for debugging. Let me just flip back now to the documentation. We can see here that we've got person. That means that if we do something like have a person, address, a meter, and a provider, the complex-ish model, bear with me, but we've got a model which is a bit more complicated than just simple properties. We've got a person object that has an array of addresses. We've got an address that has a meter. We've got a meter ID and a provider. And we can already, if you're good at this, you can already see problems and mistakes. Why is meter ID just not an instance of meter instead of it being strings? Because, every programmer likes a string, right? So with this, there's already problems that I can see with the domain, with the context of it, with the creation of it. It's not been normalized correctly. It's not fitting good business and good programming logic. So if I wanted to, I'm not going to do that now, but if I wanted to, I could restructure this really quickly. Now, I know this isn't rocket science, right? But if they were 4 or 5 different classes, all with the properties, all with methods, all with constructors, you've got a lot more goo, a lot more code to play with, and a lot more things that could go wrong. Now, this is where a lot of people stop learning. They go, right, I get records. I'm amazing. I get it. Move on. Just a way of constructing classes. And we use them then as simple DTOs instead of classes. We pass data around and the world is great. Until we hit a couple of snags like being able to change them and things like that. So what I want you to do now is just keep on now listening, because this next bit will change the way that you use records. So let's talk about spotting the difference, shall we? Records can't be changed once they're initialized. I think the technical term is mutation, right? And there are loads of libraries, including .NET, that have these immutable properties, lists, types. And the idea is more of a functional driven programming paradigm. I'll talk about that in a sec. Records can be compared with the value types. We'll talk about that as well. And it also reduces boilerplate code, which you just saw. There was a lot of code that was auto-generated and it was a lot easier to use. So let's look at these optional parameters. We've got here an age 21. I just showed you that before, where we can or cannot pass or pass in the age parameter. And of course, this will just default. Takes a little bit more code when you're doing it within a class. There's a built-in display. So if you wanted to, you could actually just display this information. Let me just zoom in a little bit. Yeah, hide that if I can. Window doesn't seem to want to hide. There we go. So a built-in display, which allows us to just output the data. The data is immutable. Now I want to talk a little bit more about this. There are lots of videos about immutability. Go and watch them if you haven't got a clue. If you do get an idea, just bear with me. If we look at this line of code at the top, these two lines of code, a lot is going on. We're creating a class, we are creating constructors, we're passing some data into them, and then we're sending this DTO to an email service. Now, looking at the code, it's kind of clear that this email service sends an email to this person. In this example, it's going to be example@gmail.com. However, because we're passing in a reference type, it's more than possible, if not should be unlikely, that the send email method changes the person. So imagine there's some business logic that you're not aware of. You weren't even here in the company when this business logic was agreed. And for some reason, person is changed. And this could be an entity, like an entity framework object, which then gets persisted to the database on the next random save changes event. Well, that's a side effect. There isn't a developer on the planet who should reasonably expect that this person object is changed or is going to be changed by this method. But this type of thing happens all the time, and it's a massive bug problem because as a developer, you just don't know. If this is a NuGet package or a third party built by a third party or another team, this could be very, very difficult to debug. You're going to have to step through that code. You're going to have to import that code. You're going to be able to have to go through it one by one and try and find out where and when and why the change was made. However, it's a mistake. It shouldn't have happened. Well, with immutability, it's impossible for the email service to make a change to that object because a person record is immutable, can't be changed. So it can't set any values, can't update any values. So that means if it wants to change it, let's, for instance, they've decided in the wisdom that this is a good idea, then it can, and I'll show you that in a second. But it does it by sending a copy back. So in this scenario, we know there's a mutation. We have got a person object, we've passed it in, and for some reason, send email has sent us a person object back. We now have to choose and understand what has changed. We need to figure out why, and we need to figure out whether we can just throw in them changes or we need to update our person object. Now that's not an update, by the way, person to person, of course, it's just a reinstantiation of that cloned copy. That one is garbage collected and a new one is sent back, which is that instance now. So it's just a swap of reference pointers. Now, we can see, again, that there's a lot of scaffolding and a lot of boilerplate code that's been done. CCAP generates a lot of this, including public getters and inits. So you might have something like this. However, what if you need to change that? What if, for some reason, you want to make the age internal, or you want to make it public? In order to do that, what we need to do now is just extend the record. And if you squint, it starts to look a little bit like a class, but we've got a record person, open brackets, open curlies, and then a constructor, which takes in the parameter list and passes that into then local variables. Now, because we've created a constructor and we want to change it, we now have to unfortunately generate all of these properties ourselves. So we've lost a lot of that syntactical sugar. We've lost a lot of that code generation because we now have to create methods and properties and things and then pass them values in. So this ends up looking a lot like a class. So if I have a look, hopefully I've got some code here that shows you. So here we've got a person. When we instantiate it, we've got a Gary Taylor 21, but as you can see, the age hasn't been outputted. And that's just a security point of view, because if it's internal, we don't want to be echoing out that age. So that way we've been able to protect that property from prying out and from third-party people trying to access it, which is a really good thing. Now, that can get a little bit annoying because it's only age that I wanted to change. I didn't want to change the first name and surname. I was quite happy with them. So what we can do is we can construct on the initializer the person, and then we can have a dedicated constructor which will take the first name, surname, and age. And note that these two constructor types don't clash. We've got one here and one here, so that's fine. So now we're able to pass in the age, but then we delegate to the base record the first name and surname. That goes into here and gets set into the properties that are auto-generated. This is the best of all worlds now, because now we can change the way that age works. We can make it internal. We can pass in the values, and when we run it, we are going to get the same thing. But we've removed some of the boilerplate code. Now, this could be amazing if you've got hundreds of properties, and you've only a couple of things that you need to change. You don't have to put them all in and add them all yourself, which is great. So let's go back now to the declaration and constructors, which is what we just talked about. Here we can see passing in age, and we can use the base to update that. So the syntax is a little bit odd. If you're used to the new classes that allow you to put the property types within the actual constructor at the top, like public, class, my person, and then the properties, very, very, very cool. Here we can mix the two, so we can get a constructor and a constructor here. Do note that there are two constructors, so it is now possible for someone to pass in first name and surname, and age then isn't set. And I'll talk about that later on. The next is checking if two things are equal. Now, when you've got a class, if you was to check them two classes, two instances of a class, they wouldn't be equal because they're not the same class. They don't point to the same bit of memory, right? But with records, they do match if the values within them match. So here we've got a person A and a person B, but they've both got identical data in them. So it's true that they are truthy. They do compare against each other. And of course, I'm just being blatantly obvious here, but if the data in them doesn't match in any way, then person A and person B is false. What I'm not 100% sure about is the locale of how it's checking it. So maybe a bit of research. If you know, put it down in the comments. What happens if I'm comparing Spanish to English, or French to German, or Chinese to English? Does it use the current local comparison? So that's an interesting question. So here we can see now Alice age 30. If they were classes, they wouldn't compare because these are two different addresses in memory. Therefore, the models don't match, or the classes don't match. Now, what you could do is you could have person 1, person 2, and person 3, and make person 3 equal person 1, and they would equal the same memory address. Therefore, they would match. Don't know why you would ever want to do that, but obviously it is technically possible. And to do that, you can use an object equivalence equals. So you can still do pointer based checking. Is this the same object? And if you had that stored somewhere, you could double check that you still had that same instance, which, you know, in some cases it is useful. Okay, changing. Well, it's great to have these DTOs, these classes, all this boilerplate code, this comparison. It's awesome, right? However, very few systems have no data change whatsoever. You know, there are a couple of things that I've seen, like APIs, which just save to databases. The data comes in and it's saved to a database. Yeah, they're simple. But most useful systems need to make changes to the data. So, if we have a look at this, we have a person, and we've got Alice, and she's 30. What I'm going to do now is I'm going to create a new instance of Alice, and I'm going to pass in the first name and the age +1. So now she's 31. Happy birthday, Alice. That's a little bit annoying, right? Imagine if there are 100 properties, that would be a pain. And there's nothing clever going on there. All you're doing is copying the data across. So there is a little bit of a shortcut. And I saw this years ago in VB, but I think it's the first time, fact check, I think this is the first time that this is actually hit C#. And it's, for all I can see, it only exists within records. And what you're able to do is you're able to take a object, a record, and then you're able to create a new instance of this record and update the values as you're constructing it. So this creates a new clone, then it updates the clone, and then it passes that data back. And we're using the with, we can actually pass in the arguments and say we want age now to be the person's age +1, and of course Alice now is 31. Not sure if I've got any code that shows that. Let's have a look. Just bear with me. So here, we've got a full name, first name, last name, and a custom full name, first name, last name. And what we're able to do is pass that in, and we're able to actually change the value. So this one now is Samuel L. Jackson.